Alright guys, I told somebody I would do this video 2 days ago, so it looks like for the fall semester, you're going to get an extension. Okay, so this is section 2.2 homework. The stopping distance of an automobile on dry level pavement traveling at a speed v, for velocity, in kilometers per hour, is the distance capital R in meters. Oh wait, what? The stopping distance is capital R. The car travels during the reaction time of the driver plus the distance b the car travels after the brakes are applied. Alright, reaction time, hit the brakes, car finally stops. Okay, here's an experiment. Awesome. Yeah, you're getting nervous, right? Okay. Use the regression capabilities of a graphing utility that you're not allowed to use to find a linear model for the reaction time distance r. Okay. So we want to find a linear model. So what we're going to do is I went to desmos.com/calculator. I love it. And I'm going to go up here. And I'm logged in. I'm going to do this instead. Plus, I'm going to do table. I'm using my pen, so it thinks I want that. Okay, so R of V. So our speed V, that's our input. 20, 40, 60, 80, and 100. Oh, okay. Now, this is asking reaction time R. So we're just going to use the values of R. We're going to put in the Y values over here. 8.7, 17.1, 25.4, 33.7, and 42.1. Okay. So we're going to leave that in our first little box. And then I'm going to scroll here to Y2, or to the second window. Now, the instructions for this are in the student help folder. So if you need to see it written out, it's on Blackboard in the student help folder. It's called Regressions on Desmos. Now I'm going to type Y1, and I didn't do anything fancy for that subscript. I just literally typed a Y and then hit the 1, and it automatically does it. And then you use what's called a tilde. It's actually called a squiggle in my head, but it's at the to the left of 1 on your keyboard, most likely. We want a linear equation, so mx1 plus b. And what this will do for us is it gives us an equation, and it tells us of the form y equals mx plus b, a linear equation, and it tells us what our m value and what our b value are. So let's write that down. Let's go here. We have our r of v is 0.417 v plus 0.38. Now this, the r squared being 1 and the r being 1, the r squared being 1 tells us it's a perfect fit. This line goes directly through it, so you could find, you could use 2 points to find the equation of a line. The fact that r is positive 1 means it's an increasing relationship. All right, so there's that. So we'll put this answer here, but I'm not going to type it yet. Why not? I know it's boring to watch a video of somebody typing things in, so I try to avoid it, but here we go anyway. Use the regression capabilities of a graphing utility to find a quadratic model for braking distance b. Okay, so what I'm going to do is I'm going to put in a new table. So I'm going to add a table. Now, see how this is labeled x2, y2? I'm going to use the same x values, 20, 40, 60, 80, 100. And I don't know. My thumb got all excited. So my b values are 2.7, 9.4, 20.6, and 36.2, 56.3. Now, I could have had this all set up ahead of time, but I wanted you to see how to do it. So a video where everything's just on a blank page is no better than a book. So here we have me typing things in. Okay, now this is y2, right? That's our table. It's x2 and y2. So y2 tilde. Now we're going to write the general form of a quadratic. We have a x2 squared come out of the exponent plus bx2. Remember, just push the 2 and it'll do a subscript, plus c. And it tells us again that our r squared is 1. We hit it exactly. So why not just type this in instead? It says round to 4 decimal places. I only had 2 and 3 here. That's all I have. Maybe I should put in a 0. We'll find out. So 0.00. It says 4 decimal places. So we're going to call this 56 x v. Use the appropriate variable also, right? Make sure you match up your variable. I almost used an x. It would have told me I was wrong. I would have been upset. 0.0014 v plus 0.44. Let's go ahead and submit these. Let's just go ahead and get those together there. Okay, good. So we know we're on the right track. It's always good to check, right? Determine the polynomial giving the total stopping distance t. Well, if we look at the picture up here, right, the total stopping distance based on velocity looks like it's the reaction time plus the braking time. And that's it. So for part C, we're going to type 0.417 v plus 0.38, and we're going to add to that 0.0056 v squared, 0.0014 v plus 0.44, and we'll add them. 8 and 4 is 12. 8. Yep, silence. Oh no. Don't add backwards when you aren't paying attention. Silence kills the video star, I'm just saying. When I'm adding, that's a 4, that's an 8, 1, 4, and our 0.0056 v squared. This is the answer that I'm typing in for C, but I'm not going to type it. And we could type this equation in, and then we can compare our graphs and we can find the appropriate graph. So this was the key part, and it is on a handout in student help folder. So I encourage you to check there, see if I have a little cheat sheet for you. But I'll try to get these videos done in a more timely fashion. So thank you for listening, and I'm sorry it was so long. Eva, wait.